All right, welcome everyone. We're going to do part 2 now, which is we're going to cover Hyperledger Indy and also do a quick introduction to a brand new Hyperledger project just announced yesterday called Aries. This talk's going to be a little higher level. I'm going to do the first half, and then Dan is actually going to give you a demo. Dan Giselle from IBM, CTO of Trusted Identity there. And my name is Drummond Reed, and I actually do have a slide or two on that right here. So my background's I'm not a blockchain guy. I've become a blockchain guy, but I'm an identity guy. I've worked on internet identity for a very long time. And I'm here because of the recognition of a large group. There's a workshop listed there, Internet Identity Workshop, happens twice a year. Actually, the last one was number 28. I need to update that slide slightly. Happened 2 weeks ago. 14 years we've been working on this problem of internet identity, how we're going to solve it. And blockchain has revolutionized my industry. And I come at this from a lot of different angles. I'm not a developer myself. I'm more of a protocol guy. And I've become a policy and governance framework guy. So what I'm going to do in my half of the talk is I'm just going to make sure you understand what is it, what Indy and Aries are about. And actually, our third project will talk about Ursa. And then Dan will dive down deeper, show you a good example, and point you at the code. So first, I just want to explain my position to Evernym. I'm Chief Trust Officer there. Evernym is a commercial vendor of SSI, self-sovereign identity, software and solutions. They were the ones that first developed the code base for what's now the Sovereign Network, helped start the foundation. I'm one of the sovereign trustees. There are 13 of us around the world. And shortly after Sovereign Foundation was founded 2.5 years ago, Hyperledger grew to the point, Brian Behlendorf came on as executive director, and we said, that's probably the best place to take the code that was contributed to Sovereign and contribute it to Hyperledger. That's what became Hyperledger Indy. And you're welcome, of course, to take pictures of any slides. Also, anyone who wants a copy of this presentation, happy to share it with you. Most of these slides are already public. And I have a link at the end, a place called SSI Meetup, where there are also webinars, but they're always lagging a little bit. So you're going to have some brand new stuff coming up here. So what I'm going to be doing is talking about Hyperledger Indy and Ursa, and then introduce Aries, so you have a clear understanding where these things fit in the Hyperledger greenhouse. I just found out from the Hyperledger staff yesterday that they're going to retire this picture because it's no longer easy. There's 2 more Solana projects now. Yeah. I'm going to talk about one of them. There's another one. Has it been announced or is coming? Not announced yet. OK. Anyway, it's going to bust out of the greenhouse. So they're going to be rearranging a little bit. You just heard all about Fabric. The one I'm going to be talking about is Indy, which is referred to as a framework. It's the only project in Hyperledger that's all about decentralized identity. There is a ledger, and I'm going to talk about it, but that ledger is optimized just to support the whole decentralized identity stack that I'm going to show you. The crypto there was, to my knowledge, the only zero knowledge crypto in the Hyperledger project. And again, we were ways down the road at Evernym, the Sovereign Foundation, before we contributed it. And a wonderful gentleman named Dave Huseby, the security maven there, said, you know, you guys are far enough along. I'm going to turn what you're doing into a best practice. And he managed to convince the rest of the projects they should combine all their crypto into a single library that all the Hyperledger projects can use and anyone else, right? Classic, peer-reviewed Hyperledger library. That's Hyperledger Ursa. Fantastic project. It's got the densest community of cryptographers, cryptographic engineers around it that I've been involved with since like libsodium. And I would, don't know any of those guys. So highly recommend it if you're interested in the crypto. Ursa. They have like weekly calls and their own working group now. All right, so as I said, I'm going to talk at the end about Aries, brand new project. As I said, but I'm going to explain exactly where that fits. So first, I just want to make sure we're all on the same page about what is this new thing called SSI. This is where I always do the same thing. I'm known for. Here's the wallet, carefully redacted. Self-sovereign identity, it's just not digital. So to complete the whole thing, I only need one other prop. Self-sovereign identity is getting this onto this, okay? Now, I'm not talking about the currency in this wallet. That would be a nice Benny. I'm talking about the identity credentials. We all know how to prove our identity in the real world today. If you took a plane here, you didn't have to do it probably if you got on a train. Actually, you did if you get your ticket. Took a plane here, you had to use some credential in this to get on that plane or you weren't going to get here, right? Now, you probably, how many folks used a mobile boarding pass to get to this conference? On their plane, okay? You know how to do digital. It's just that it only works on a proprietary wallet in your device, Apple, Android, whatever, with technology that's built in by those OS vendors. What we're all about doing is saying we need to have a wallet that's as standardized as this one. Meaning there's actually a standard size format for credentials that fit into physical wallets. Well, obviously we're needing to do the digital version of that. That digital version has been underway for the last 2 years at the W3C in a working group called Verifiable Claims. The actual format's now known as Verifiable Credentials. And this is the one and only diagram you need to understand verifiable credentials, what they're all about, the digital version of the credentials we need to prove identity or attributes on the internet. And I just want to make sure it's clear when I use this diagram. These three roles, and I've got another slide coming up here. Well, actually, I'll show it to you very quickly just to show you. This is what's called the trust triangle. This has nothing to do with technology. That has to do with how trust is transmitted in the real world. The reason this works is because somebody issued me these credentials, the issuer, and some verifier like TSA is going to accept that. They trust those issuers, right? It happens they trust 50 states in the US plus the US, the passport authority, okay? If you're traveling the US, you know, it's different authorities around the world. All we're doing is turning around and saying, okay, we're gonna take this same thing and put it online. Issuers, any place can issue credentials. Holders have their own wallets. That's the self-sovereign part. I own this leather here. You're gonna own the wallet that you have. IW 2 weeks ago, we had 8 different wallet implementations. None of them yet perfectly interoperable. 3 of them were actually working together, but that's what we're driving towards. And notice in this diagram we have verifiable credentials issued into your wallet, but when you present that, you don't necessarily show the credential. You show a proof of the credential. And there are different ways of doing that. In Hyperledger Indy, we've implemented zero-knowledge crypto, so you're always providing a zero-knowledge proof of the information that's in there. If you care about privacy, that is selective disclosure by design. It's a very powerful new feature, and I don't know of any other projects implemented it on the scale that is now happening. So just to, again, complete this picture, issuer goes to the holder and prover, it goes into their wallet, they go to any verifier who requests a proof of whatever it is that that verifier needs to know. And that means you can now standardize proof requests for many different places, whether it's anything from website login to the TSA saying this is what you need to get on a plane in the US, and their equivalent in France and Germany and Australia, all standardizing their proof requests. Now all the wallets and all the systems know how do you answer that and how do you do it in a privacy respecting way. All these things rely on digital signatures. That's why you see at the base, this is where blockchain comes in, technology called DIDs. It's basically how we do decentralized PKI. So I showed you this. I'm going to show you one more thing here that's important to understand in order to understand the whole stack. So that trust triangle on the top, how do you scale it, right? How is it that I can go into any merchant in the world right now, I'll be very specific and pull out one of these, and the merchant, not knowing all the banks in the Visa network, is able to take this piece of plastic. It's because it's not only technically interoperable, there's what's called a governance framework behind it, and all of the merchants and all the banks in the Visa network have subscribed to that, legally to that framework, okay? That's how trust is done at scale. We're doing the same thing here. Once again, it's referred to as a governance authority. And how will governance authorities turn around and acknowledge all the issuers in their network? With a verifiable credential. Which means, from a verifier standpoint, the actual software that they will be operating to verify a proof, they'll say, hey, I need to know, I'm going to give you a specific example here. CU Ledger is a consortium of the credit unions that has formed to leverage blockchain technology and verifiable credentials. One they're defining for credit union membership is the whole initial thrust of that. They have, I think there are 65,000 credit unions around the world. They're going to enable any credit union to issue this credential to a member, and any other credit union or any verifier anywhere is going to be able to accept that. But how do they know it actually came from a credit union? They're going to run what's called a Credential Registry of all the credit unions. As they're authorized and they get certified, now any verifier is going to be able with 2 proofs to know, yes, you're really a member of a credit union, it's a real credit union. There isn't anything out there on the internet that can do that kind of stuff today. All right, now just quickly, because I'm the co-editor of the DID spec and I want to make sure you understand this other piece, what are these decentralized identifiers? They are a new type of global unique address, very much like a URL or a URN if you're familiar with those, that the whole web runs on, but they don't require any centralized registration authority. It's very different than DNS, okay? This is really where blockchain comes in. Most of you here in the US, you recognize that identifier, right? Right? Now, if I ask you right now, how do you prove to me that that's your social security number? If you put one of those numbers in front of me, how would you do that? Right. There's almost no way you could do it just sitting here talking to me. Sure. As it happens, if you want to read the story about that one, it's on Wikipedia. 40,000 people have used that because it was printed in a wallet that was sold back in the 30s. So the IRS, in it was about a year ago, attended a webinar where they said, if they replace the social security number with one of those, an actual DID, they felt estimated they could save $20 billion a year in tax fraud in the US. So that your tax return is not filed by someone else in Russia, for instance, before you do it, and they've already claimed the refund. Now, how do you prove the control of a DID? The DID is an address of a public key on a blockchain. Any blockchain. Public, permissionless, permission like Sovereign, Ethereum, Bitcoin, Verus1, private blockchains, any blockchain we're talking about here, they can all support what we call a DID method. You have the private key. Where are you going to keep it? All depends. The individual is probably going to keep it on a device just like I keep my address book here, right? Enterprises are going to keep them in the kinds of places they keep their keys today, okay? They're all wallets, they're just different scale, but they all can interoperate the same way. The other thing that's different about DIDs is, unlike a social security number, you're not just going to have just one as an individual. You're going to have thousands of them because they're going to be, most of them are going to be what we call pairwise anonymous. Whenever you form a connection with someone, which is going to be as easy as getting on that plane, it's going to be Bluetooth, it's going to be a QR code right here, it's going to be all the different kinds of ways we can do that. There's no intermediary. That's a pairwise synonymous set of DIDs. It's called the DID peer method. That means every one of those DIDs is not just an identifier, it's not just a unique pair of keys, it's a channel. It's a channel you can use for anything you want between 2 people, organizations, and things. SSI is as much for the world of IoT as it is for people or organizations. And again, DIDs, also W3C standard. I'm the co-editor of the spec of the Credentials Community Group. We expect within the next 2 months a vote to actually form a DID working group at W3C. This will be the first identifier in the history of the W3C besides an HTTP URL that they actually standardize. And it's all because of these cryptographic properties. Now I'm going to wrap up just by putting this in perspective. What's that? Oh, Dan's not ready yet. Is that what he's saying? Yeah. Okay, he needs a little bit more time. Well, that's all right. I'm not done yet anyway. Now I'm going to give you the big picture perspective to understand Indy and Aries. Okay, so these technologies I just told you about, they form a stack. And this stack is now starting to be recognized a lot more widely. You're going to see these same pictures and a whole documentation of the stack in something called the Sovereign Glossary, which is part of the Sovereign Governance Framework at the Sovereign Foundation site. So you're welcome to take pictures, but again, you can get all of this right there. The bottom layer of the stack, layer 1, is the DID layer. This is where we get the strong cryptographic roots of trust that today are confined to about 200 certificate authorities around the world, and the addresses for those are built into things like your browser. It's not bad, but it's not decentralized, and it's got a lot of issues. Now we're saying any blockchain can serve as a strong root of trust for a DID for some issuer of credentials. The second layer is the layer of actually doing where the wallets and what we call the agents. And again, if you want to understand the agent, think this is dumb. This actually doesn't do anything unless me, the human agent, actually operates the credentials, right? Well here, yeah, the silicon, the storage of the wallet is fairly easy, but exchanging keys, forming connections, exchanging credentials, you need a standardized piece of trusted software to do that. In Indy and in the infrastructure, we call those agents. So this whole layer of credentials and exchange of pairwise synonymous DIDs and credential exchange, this is all off ledger. We can scale this to the moon, and it's not going to run into any issues of blockchain scaling. An example: sovereign ledger today, 11 transactions there, and the governments of BC and Ontario have issued over 10 million business credentials in production. The first widespread issuance of credentials out there. So these first two layers form what we call the cryptographic trust infrastructure, also called the identity metasystem. There is, other than just trusting those blockchains actually are run right, and the software that you're running is certified or comes from a vendor you trust, there's no human trust at this layer yet, right? It's like forming a TCP/IP connection. Human trust is what we can now layer over this cryptographic trust. The first layer is the one I just talked about. It's the trust triangle. It's every credential from every issuer to every holder and every verifier that agrees to accept that. And again, as I pointed out earlier, how do you scale that? You do it with governance frameworks. There will be thousands of those versus, for instance, the 3, 4, 5 we have for credit cards today. That's a very, very specialized governance framework. Now we're moving in the direction much more generalized. At the Governance Framework Working Group at the Sovereign Foundation, we have 5 of what we call the domain-specific governance frameworks that are now started. We just finished the 2nd generation of Sovereign Governance Framework a couple weeks ago. Dan's, by the way, a member of that working group. How's it going there, Dan?
I'm good.
Good, because I'm almost done. Now, go ahead.
So, with the thousands of these identities floating around, did you consider working on 2 or 3 base identities that could be the root of trust for all the other identities that may be required, like a passport or a driver's license would be? Because these are, I can use either one of them to establish my identity in the non-digital world.
Yes.
Why couldn't I have done the same thing in the digital world?
You can. So one important thing about this stack we're talking about here, it's not itself an identity system. It is a technical, in other words, like, to use an example, if you took the TCP/IP specs for the internet stack, that's not the internet. You got to go out and actually build all the routers, and you got to run it, right? You got to have actually operating infrastructure. Same thing is true here. We're defining this. The Sovereign Foundation and Hyperledger, they don't actually issue any credentials. They're going to issue a few within their own ecosystem. The whole idea here is now the real issuers of the world, the issuers of the actual credentials in this wallet and your wallet and wallets all around the world, will start coming on board. Like the British Columbia government, the first thing they decided to start issuing was business credentials. Why? There are no privacy issues. They're all public documents. So I said, let's take existing databases we have of that and actually start issuing them, and this is what this role up here of Credential Registry. You probably recognize all those other terms if you're familiar with cryptographic infrastructure, except Credential Registry. It's like, what's that? It's the new form of what we call CA today, which is a very manual job. Credential registries are now literally holders of credentials from any issuer that says, by the way, this credential is not just valuable to you, Mr. Business Owner, it's valuable for me to publish to another holder, a credential registry, publicly searchable in that province. Now again, this is in production, vonx.io. Go check it out. You can review all the credentials for businesses in either BC or Ontario today. Go ahead.
So what's going to happen to my digital identity if I lose my private key?
Since I only had 15 minutes, I cut out that part of the presentation. But I usually actually set a stopwatch and how long it takes that question to be answered. I do have a great reference for you, though. It's called DKMS, Decentralized Key Management System. Just put that into Google, and you will find the 2-year project that we did for the Department of Homeland Security here in the US about how we're going to standardize interoperable digital wallets with full recovery features. Not only conventional offline recovery like a hardware or a QR code, but social recovery, which I think I'm a big believer in. Social recovery is when you use other people or organizations to actually shard your recovery key. So anyway, it's a great question, and I hope I answered the other question about all the issuers out there that do credentials today. And I think the same thing will happen. Certain issuers will say, I'll issue a credential like a bank if you can show me a driver's license or a passport. And what will happen is first you'll have to do it manually. But slowly, just like things slowly went onto the web, if people remember that, I'm old enough to remember that, Go ahead. All right, I'm going to finish up because, Dan, we need to get you up here, okay? Here's the deal. Today, when it started, Hyperledger Indy was a project to cover all three of those layers. The code was contributed. There's a ledger there for layer 1. There's a wallet and an SDK there for layer 2 that actually speaks a protocol. And there is a credential format and signature type, zero knowledge proof. That's one of the 3 types being standardized by W3C. The candidate recommendation is already out. Here's what's happening. This project has become, Salona can tell you more, one of the most active projects there. And first, the crypto library got pulled out into URSA. And now what's happening, what we announced yesterday, is Indy itself is shrinking down to be just the ledger layer, okay? Specialized layer for SSI. And the other 2 layers, all the code there that's been called the Indy Agent Project is now Hyperledger Aries. First Hyperledger Aries working group meeting is this afternoon. It's a weekly working group, and they literally just had to change the name because it's one of the most active development communities I've been part of. So there is one article on the, I checked this morning, you just Hyperledger Aries, make sure to spell it right, A-R-I-E-S. You can read the press release, they've put in the links, you can go over and check it out. This is the new project. You can see from this diagram that's in the write-up, it separates out from Indy the ledger layer, all of the, they call quality and agency things, and then all uses the URSA library. Of course, any application can go on top of that. And you can use any storage mechanism. So think of the same thing will go on a phone or even a small embedded device for an IoT device. And meanwhile, like BC Gov and Ontario are running wallets with millions of credentials in them. So the whole spectrum. And I think that's all I've got. Dan, are you ready? Yep. All right, I do have this one picture. I had to show off this picture of the agent universe that we hope Aries is going to enable. All right, I'll turn it over to Dan, and then if we have time after that, we'll take more questions from both of us. Okay, you ready? Get this off here. Oh, I probably should have explained that a little bit more. The 2 things, one was a lot of folks were coming into Indy and thinking, well, it's just a ledger, right? Because it is started as a ledger project. But the other one was it became very clear that it needed to be ledger independent. In other words, Aries needs to work with any ledger. We have Ethereum folks, Bitcoin folks that are there. There are a number of, and then there are also going to be multiple Indy ledgers. It's not just Sovereign's the best known, SOVRIN if you want to check it out. But Dan's going to talk more about this. But other Indy networks are coming. So we need something that's ledger independent. Adam Gunther at IBM coined one wallet, one experience. That's what we want.
We also had a large discussion about modularity in regards to Hyperledger itself. And Indy has kind of been like one of my star pupils in regards to whenever I sit there and see things that I think could be broken out, they just start breaking it out, like they did with URSA with the security and crypto aspects of it. And because of that, it's actually able to grow to where now we're talking with the Chinese and Russian governments about bringing in their certified crypto, so that way we can make things be more international.
All right, my name is Dan Giusolfi, and I'm the CTO for Trusted Identity for IBM. And Drummond and I, we work very, very closely on a daily basis. You should be, what you're getting here is literally information that's hot off the press, if you wish, and is maturing on a daily basis. Drummond just showed you a chart about a project or how we're trying to articulate to the industry the entire stack around decentralized identity. It's not just about some of the standards that are there, decentralized identifiers, DIDs, W3C verifiable credentials. It's about up and down the stack, everything working together. And we're trying to work with the Linux Foundation to bring attention to the entire stack, not just pieces of the stack. So what is a good follow-on to what Drummond just gave you, what I'm about to show you is an introduction to a technology preview from IBM on how we articulate the componentry to make sure that stack is possible, all right? So I'm going to go through a demonstration. Just by a show of hands, how many people in the room are actually developers? Okay, so before this is over, I have an invite for you to go, and if you want to kick the tires with this tech, you need to understand that if you have zero tolerance for dealing with emerging technology, do not take the invite, right? It's a pre-alpha, right? But we feel that in this industry, the way things are evolving, if you are interested in this space, you'll be willing to evaluate, give us feedback, and get us to the point where this will evolve much faster. So with that, I'm going to bounce around a lot, so please bear with me. Let me see how this screen's actually, oh, look at that. I have more space on that screen. Beautiful. Okay. What you're going to see on the side here is my phone. Okay, and the first thing I'm going to do is I'm going to actually, so for the first thing I'm going to do is I'm going to actually give you a little bit of a tour. So we have, if you take the invite, we have a set of open source technologies that we've been contributed. First thing is we've taken Hyperledger Indy as it stands today, prior to Aries, and we've written what's called an agency, or for agents. And how many people use Dropbox or iCloud or something like that to share files? Oddly enough, somewhere those service providers have a cloud. They're using a cloud. You don't even know. I use Dropbox. I don't know where Dropbox's cloud is, and I don't care as a consumer. The model here is you have, similar to file sharing of sharing of files, you're going to share credentials through your cloud provider to all your devices in a synchronized model. All right, so as Drummond gave you the wallet example with the credentials, we're trying to make that digitized. So what we've done is we've taken Hyperledger Indy as a code base, as an SDK, and put a wrapper around it. In this case, we started off with Node.js, so a developer can come in and not have to learn the cryptographic GORP, if you wish, of Indy, and have a higher level API to just create issuers and verifiers. All right, so I think that was on one of Drummond's charts. You have roles in the industry about issuing credentials and verifying credentials. So there's a toolkit for that, but we will go one step further, and this is all out in GitHub. We have a set of samples, and I'm going to actually show you the running demo of these samples going forward, okay? So if you do this, bring up this code, you will actually have this all up and running. And what we do for you is we actually set you up in our environment in a sandbox. You're going to run through the same demo live, and then you go to the code and you build it yourself. And then if you get through all that as a tutorial, we believe you should be able to go off as a developer and start creating your own credentials, right? And verifying your other credentials and try to kickstart that ecosystem. All right, that's the goal. With that, what we've also done is, as Drummond pointed out, most people believe that they're going to be putting your digital wallet on a smartphone. But we have many different devices that we interact with. It's not just our smartphone. A lot of times I'm on my browser and I'm interacting with the website. Why can't I use an extension to my browser to interact with my agency where all my credentials are held, all right? So we've made available on Chrome, through a Chrome extension, a tool to allow you to actually interact, and I'll show you that with your agency. We have our documentation. Again, all this is going to be available to you, but essentially this will walk you through. And we have a couple of our teammates in the room here, Millen and Rachel and Alan. And Rachel has actually given us a nice guidance on very quick steps on basically you're going to prepare for your environment, you're going to explore and go through the demonstration that I'm about to give you, and then you're going to kickstart and do some development, and then you're going to promote. What we mean by promote is you're going to say, okay, here's a credential, folks. Who else wants to use it? Go get an app, go get a wallet, and actually go through the process, right? We were joking here that maybe next year, by the time we get here to consensus, that we won't be wearing these things, right? Drummond and I will be actually using phones, and you'll be having your credentials on your phone. The other thing we have is a set of Swagger APIs. So for your developers, this is all available to you to understand the full APIs as you go through the process, okay? And let me just close out of this, and let me come back. So the first thing I'm going to do is I'm going to log into my agency. And remember, I'm logging into a cloud account. Now, in this case, with IBM, just like if you go to Apple or Google, you come to IBM, you create an IBM ID. And creating an IBM ID, we spin up for you on our cloud infrastructure an agent account or agency account. And in that agency account, you have many agents. I'm set up here for one agent. Now, what an agent is essentially it's a cloud endpoint for all of your devices to be synchronized with, all right? And to act on your behalf as an adjustable endpoint. So now that I have my agent, you'll see, do I have any connections with other issuers? I don't have any connections right now. We're going to start to build those. Do I have any credentials with those connections? No, I'm vanilla here at this point. I'm just starting off. So the first thing I'm going to do, and we have the scenario that we built, we're going to walk through, is we're going to go get a credential from a government institution, a driver's license, hypothetical. We're going to get a credential from an employer, in this case, IBM's the employer. And then we're going to go to a bank. And with the bank, we're going to apply for access to log on to my online banking account passwordless. So one of the pervasive patterns we've seen at IBM is passwordless authentication. We all know how many passwords we have, and we all forget them. What if I can just log into my account passwordless with my digital credential? So we're going to go through this whole process, and we're going to use the two credentials, government ID and employer certificate, to log into the bank, all right? So that's the flow. The first thing we're going to do is we're going to start off with, I'm going to actually turn on my, my browser extension here, and it's going to log in. And you'll notice that my browser extension is now on, all right? I have installed it in there. And what that means is now, once I go into my, my account here, I'm going to log into my HR account. Oh, let me just refresh this here. And well, that's not good. Sorry about that. I thought I had that broken. Oops. Demo gods are not with me right now. Let me see here. I'll log in. I am logged in, and my connections are on. All right, we'll start a different way. What I'm going to do is turn this off, and I'm going to actually log in with my mobile app. All right, so let's start off with just getting a government certificate, credential. I've logged into the government ID, and I'm going to bring up my mobile app on the phone. Okay, and just to have everybody understand, what I've done is I've provisioned my mobile app, as you can see, to point to my agent. And now I'm configured for that agent, and right now I have no credentials in my wallet. I have an empty wallet. So the first thing I'm going to do is I'm going to come down. I've logged in as Alice Garcia, and she's going to request a credential. And what's going to happen here is I'm going to get a push notification to my device, if everything's working, and there it is, okay, saying, do I want to establish connection with the government? I'm going to say yes. And the next thing I'm going to do is it's going to present to me a credential invitation, and I'm going to accept that invitation. So there it is. Now this is for a driver's license. Now what's happening here, and the goal here is that this should be very seamless to do for the user. I can click on here and you can actually see the driver's license, all right? And you'll see that there's all the attributes that are in a digital driver's license. Now, I just want to make sure everybody understands, under the covers of plumbing, Hyperledger Indy is used to cryptographically sign every one of those attributes, right? And that's what you saw going past between the cloud agency and our device. What's more, and I want to make sure that everybody understands this, everybody thinks, oh, take a picture of your driver's license, that's good enough for security. No, that's not what we're doing in this space. And just to make sure you understand that whatever we do in this space, we want to make sure that we can be coexisting with existing technology. In other words, can I use my digital driver's license with TSA? So as Drummond pointed out, not only my boarding pass, but my driver's license. So I have here, you'll see at the back of is the barcode. I can bring up a barcode scanner. I'm just going to bring this up and actually just prove to you that I can read this. You'll hear it. There you go. And it was actually read. And if this is a real ID, all the information we actually put out there for you. So what does that tell you? We were able to cryptographically use Hyperledger Indy to not only create a digital credential, but have in that digital credential the attributes that are used or capable of being used with existing readers that are out there in the ecosystem. Folks, if we want to achieve the vision of self-sovereign identity and decentralized identity, we need to make sure we can gradually bridge users, consumers, through existing tech to the new tech, right? It's an evolution. It's a journey, as some of us are talking about, right? So we've done that. The next thing we're going to do, back to our example, we're going to go and I don't know if I'm going to be able to get this driver's license, this ID here. Let's see. All right, let me see if I can sign in. Let's just say it to me. Don't know why it's not coming in. Millen, can you do me a favor and check to see if the ID is killed? Yeah, yeah, I can. I can create a new one. Yeah. All right, let's create a new one. And get that one, and let's upload a picture, Dan. All right. Well, this is an interesting feature. I'm glad I did this anyway. So one of the things that we focus on with IBM is Gdpr. Everybody familiar with Gdpr? Right? In this space, this is one of those. Gdpr is good because it gives us principles for guidance on what we're trying to do here, but it's also regulation. And so what we do is we make sure that when you're using this tech, you're going to be putting information to a database. So we want to make sure that you're given agreement that you're not going to be putting personal information just as on our database. So we're creating the account. All right, so now I have an account. Okay, there's Alice Garcia. And we're going to issue the credential here. And the same thing's going to flow through. Same flow now, different issuing institution. The issuing institution here is my employer, being IBM. All right, and I'm going to accept the invite.
And this is assuming that you've done enough identity proofing before you issued it?
Thank you for the question. This is the most confusing part for everybody in this industry. Everybody familiar with KYC? It's a derailment term, all right? What happens, today, the DMV has a system of record for you. IBM is an employee in this example, if I'm the employee. They already have me in their system of record. They've already vetted me. We're starting from that point. All of the examination, vetting of your credentials or of your attributes, that is a priority of this exercise. It's prior to this flow, okay? I'm not saying it doesn't get done. It's just that this tech is not dealing with that. We're making this, we're assuming, it's not an assumption, no, not at all, not at all. We're building on, so if I took this code and dropped it into the DMV already has workflow, they press a button at the clerk and it goes and prints out your driver's license or sends it to a company to do that. All we want to do is drop in the same code and when they hit print, send it also to a digital credential for you and have it instantaneously sent down to your device as opposed to going through snail mail, right? Okay, so we now have two credentials. We're going to come over to the bank. And now I have, as we say, Alice has been building her digital reputation. She has two credentials. She's going to go sign into the bank and say, the bank now, so for you folks that deal with enterprises, the interesting part here is that we can now help enterprises establish policy, digital credential verification policy, assuming, back to your KYC kind of question, assuming that I'm going to trust other issuers out in the ecosystem. If the person comes to me with digital credentials in their wallet, I can now have policy and establish a proof request based on what I require, based for what they're coming into. In this case, the driver's license and a proof of employment is going to be required. So I'm going to fill this out here, and I need to get my URL here. Oh, I'm going to actually show you this. So what you do is you can come right over to our account, and you say copy to clipboard your agency account, and you just drop that URL here, and this binds you to, that tells the bank, where's your cloud agent so that we can contact you, so we can make a connection. Quickly that is established. The bank is going to now say, I'm going to make a connection to your device, and they're going to say, we've told you that these are our policies, we need these 2 credentials. We're going to send you a proof request. By the way, the schema for that proof request is also defined in Hyperledger Indy. That proof request is going to come down to the device, and now what's important here is that the device is, oops, sorry, I'm not showing the screen here. The device is actually identified in my wallet what attributes are being asked for and which ones do I have. In this case, I have 2 credentials, and you can see on each side, it's pulling from the 2 credentials, and those are the icons from each credential. Anybody hear the term selective disclosure before? All right, in Hyperledger Indy, we talk about the selective disclosure. What that means is I could, based on consent, deselect some of these attributes and say, I don't want to share it by choice. Now, be it known, if I don't share it and it's being requested, I may be denied my interaction. But the point is that the application allows you, the technology allows you as the individual to give consent when necessary. So I'm going to send that over. And now what's going to happen is, in this case, the bank is both a verifier and an issuer. So they're verifying right now all the information I've sent over, and they say, oh, that's good. You've passed muster here. I'm going to send you now a credential from the bank. And now the bank is going to use that credential to log me in. So now, I now have 3 credentials in my wallet. I'm going to log out of here. And now we're going to start one last exercise. Now imagine the passwordless auth situation. I now come back after provisioning my bank account with my digital credential. I'm now going to log in with my digital credential. All I'm going to provide is my username or email address. That's bank's policy. And the bank now knows that I'm already a registered device and I have a credential. It's now going to send me a proof request as a verifier for their credential, their bank credential. They're no longer going to ask for all the other credentials they did to vet me. They've done that the first time digitally. Now they're just going to ask me for their credential. And voila, I'm going to be logged in through to the bank website without having to remember my password or not. So as an example, let me just give you how powerful this is. How many of you work for a company that uses ADP for payroll, for example? Okay? And those of you who do, how many of you have to struggle at the end of the year when you go to get your W-2 for taxes, right? You only use that password once a year, right? It's terrible. This is where this comes into play, right? It's in my wallet. I don't have to remember it, right, as an example.
I still need to remember my username.
Well, so there's always going to be, well, okay, here's an example. How does the verifier of all of its possible relationships, right? I'm a bank. You're all my customers. How do I know who's contacting me?
An identity claim.
Right?
Should be an email.
Any sort of indicator. It could be their account number at the bank, whatever you want, right?
Have your digital ID that knows your name.
What's that?
Have your digital ID on your phone that knows your username.
If you have the digital ID, then for the phone, that's specifically tightly coupled to the bank, right? Is that what you're asking for?
No, I'm saying your digital ID can provide username and the password. You can solve 2 problems instead of solving just 1 problem.
But the bank needs to know how does the bank know which agent they're talking to? Who's the representative, right?
If the bank is this way, the QR code or some other way of letting you know who it is that's asking, your agent can actually turn around and provide all of it. Dan's not showing that flow here, but there are other examples who would do that. So you're right, you can in many cases also give it a username.
Yeah.
I was going to say to the experience question where you have to remember the username, like that could be embedded as, again, this is part of business policy, that again, if you
So these are, right now this is in the bank account credential, there's an account number, right? There could be as Millen said, there could be a username or something else, but the point is, to make this flow happen, when I'm logging in, at this point when I'm logging in, if I log out right here, let's go do this again, okay? It's an arbitrary website. Someone's come to the website. They're asking to log in digitally. How does the bank know, if you're going to ask to log in, how does the bank know who to communicate as a cloud endpoint to challenge, to send the challenge to? You don't know. There's got to be some indicator so the bank can look up and say, okay, I have something about that person so I can go send a message to. What's that indicator? It could be email, it could be username, it could be account number, whatever the policy is, right? You have to know something. It's inconvenient. So
If I go to your bank on my phone, then I already have my identity. Like, why are you asking my username? I'm on my phone. My phone knows who I am.
You can be logging in from a desktop.
yeah, but this is a desktop login. This is on. I see what you're saying. If I was coming into a mobile app, using my mobile application, that's a different interaction, which is what Drummond's saying. Well, no. This is fantastic. If you have an idea how to solve that, come join us. Come to the work groups.
It seems to me that you solved like one problem we would have said. But anyway.
Like I said, come join us. No, don't. Come join us and contribute your ideas. This is what it's all about, right? Come and what's important about your comment, it's use case driven. We welcome the use cases. We want to drive everything by the use cases. So if you have a use case where you can come to an online website without entering any information, rock and roll. Let us know, and we'll get. I mean, that's more of an improvement that we have right now. That'd be great. Other questions?
How the interoperability will go? I mean, let's say bank A will accept the driver's license, but bank B, no, I don't want driver's license, bring something else. So
But-
how that
Okay, so great question, and I'm just going to rephrase it a little bit. How does each verifying institution have interoperability with the different types of credentials that are out there in the ecosystem, right? The first point is it's policy driven. This bank decided on driver's license or a government ID and an employee credential. One bank may say it's a driver's license, or maybe they may say a passport. Whatever their policy is, that's what you're going to have on your credential, and you're going to have to go make those, in your wallet, you're going to have to make those connections, okay? So, one second, there was a question behind, go ahead.
How do you see the interoperability of this with FIDO?
With FIDO? So there are levels of authorization and authentication and authorization as you connect to an endpoint. FIDO is used as you build up that way, just like the biometric of me getting into the device is part of that authentication and authorization process, that level of trust. So this is you could combine FIDO with what we're doing. What we're doing here with credentials is around the authorization aspect, okay?
The FIDO enrollment also ends up generating a crypto.
Because what they're establishing is strong device authentication to that institution, right? And a lot of the banks do this, right? So it's again, I would say it's a value add. This is complementary, right? If you want to comment.
FIDO and WebAuthn, those groups are now working with the DID, Credential Community Group, the W3C, and WebAuthn is saying, okay, the next version of WebAuthn, they just finished the current version, but the next version they want a DID enabled.
Yeah.
So both of those as authentication methods are using the same underlying basic architecture of public-private key, right? And that's the basis. DIDs add a continuity. So FIDO currently, as you have a unique key pair for every site you've got to find a relationship with. With DIDs, you're adding the continuity and a channel that can be used to not only for additional authentication, but for all the other uses. So it's an evolutionary step that both FIDO and WebAuthn should be taking.
That's a really good point that Drummond's making. Some of these standards that are coming to play are not trying to replace old ones, but trying to fill gaps. And as I say, the beauty of it is we have a lot of ingredients now. We need to make some pizza, right? And in this case, there's going to be different variations of how these things come together. But we're trying to show the basics here without trying to bring in too many derailing topics, right? Because with identity, as you know, it can become very heavy discussions. Other questions? Yes, sir.
They handle revoking the credential. So if you're the state and
Yeah.
longer a member of the bank.
Right, so revocation of the credential, how do we do that? So this is a topic that is going to be being addressed inside of Hyperledger Indy right now. There's a couple of ways to go about it. There's a revocation list that would actually be put up on the ledger and managed on the ledger is one way. We have to think about what the proper way to go about it is right now, and it's right now it's not implemented into the spec, right? I'm sorry, not implemented into the code base.
The really exciting way to do it with zero-knowledge crypto is to maintain a cryptographic accumulator on the ledger, which basically just a cryptographic product of all the issued credentials from a particular provider. And all they have to do is update that one number as soon as they revoke a credential. And what happens is the holder of the credential is actually issuing two proofs to the verifier, a proof of the credential and a proof of non-revocation. The moment that the accumulator is updated on the ledger, the second proof will no longer verify. So you can get near instantaneous revocation without any of that. Obviously, if you put a list of revoked credentials on the ledger, big privacy problem. Cryptographic accumulators solve that problem. We just, as Dan said, the design is there. Actually, a lot of we're now taking it all the way into implementation, so the credentials can. We have
3 minutes. So other questions? Yeah, go ahead, hold on. No?
So each of the identity provider would just be a node then?
No. Yeah, so let's this is where it gets, we should have the chart up again with the issuers and verifiers, the stack.
Well, Dan does
that's
that.
right, the layer.
Yeah.
The bottom layer.
An identity provider in the traditional mode is now an issuer of credentials.
Correct.
Right. And
do
the
this.
question is asked frequently of Sovereign, for instance. So Sovereign's a public permission network in layer 1.
Right.
Stewards of that network may or may not be issuers of credentials. Many of them are because they're interested in being part of that, but that has nothing to do, right? There's different.
This is what we want to talk about, is that these are roles. And as you saw with the bank example, the bank in that interaction played 2 roles. It played first a verifier and then an issuer of credentials, okay? In the case of the government, the first one we did, they were just an issuer, and the same thing with the employer, okay? So when you're writing code here to implement these scenarios, you have to decide and go through this very simple diagram each time. Who are the issuers? What is it that they're issuing? What's the data model for the credential that they're issuing? Who are the verifiers? What's the data model for the proof request that they're going to use? And put it all together. And that's the framework we've made available to you. So the gentleman in the back's question around the KYC aspects, how does the issuer know that the data that they're going to, the claims that they've made in these credentials, that they believe in, that they're attesting to? Well, that's a separate process prior, and I call it the examination process, that maybe it's a very regulated and compliant-related process that a bank does for KYC, but maybe it's something as simple as, I take someone's passport, I scan it, and go use a passport service, and I get a bunch of information out of it. And now I have information in my system of record. That is prior to the issuance. Okay? Question?
The attribute sharing, is it based on OpenID Connect, or this is a different protocol now?
Yeah, so now this is all peer-to-peer. As Drummond and I always say, you're moving to the edges of the network, and you're no longer sharing information back to a central point. We're now going peer-to-peer, and what our team wants to make really happen is, I can actually peer-to-peer, device-to-device connect.
But is that also now a new standard, so the endpoint knows how to request it?
Remember the chart about Aries? Yeah. That's where it's happening.
Important to clarify, the W3C Repakula working group was only authorized to standardize the format and the signature of the credential.
Yes.
Protocol was out of scope. Protocol's coming, but what's going to happen, and one of the reasons, again, that Aries was created was everyone's going, now we need to agree on the protocol.
Yeah.
That's where it's going to happen de facto. So if you're interested in that protocol, I think it'll be widely implemented before it gets to the standardization.
That's why you have layer 2 and 3 here, where you see on my chart, it's Indy now, but it's Aries coming forward, and that's what we're trying to get to. So as I said at the top of the demo, is everything you're going to see here is literally bleeding edge. This is happening in the open source, but at the same time, we want folks to, like yourselves, to join us, to start to kick the tires and see, and where you have contributions, whether it's ideas or code or whatever, to please join us. And so I'll say again, here's, if you want an invitation to join us to get some access. Again, I will tell you that even like me getting up here demoing, it's a little clunky, but that's okay. I feel it, if you're in the emerging tech space, you'll be able to tolerate that, okay?
And there are rocket chat channels.
That's right.
Hyperledger has rocket chat channels well, they just opened the one for Aries, but Indy maintainers and Indy agent is now Aries. So, and they're really active channels. I mean, so you can get asked all kinds of questions. It's really a great development community. Thank you to Salona for helping as the community architect for Hyperledger make that happen.
Yeah, it's chat@hyperledger.org, and then you can subscribe to the various channels that happen there.
Yeah. All you got to be is a Linux Foundation member. You don't have to be a member of Hyperledger or any of these particular projects.
And there's no fee for just getting an LFID, so you can just join in. And
Yes.
also, you can contribute code without being a member as well.
Right. Okay.
And yes, we are going to work with the Linux Foundation on that. Even if we don't have consensus enabled in this next year, we do want the Linux Foundation and Hyperledger to actually be enabled to do this. And for you hardcore developers, the did-get method is under development, being led by Dave Huseby at Hyperledger. And I think it's actually going to be implemented within the next 2 months.
It's basically a good way to maintain the licenses on every single code commit that comes through via the DCO. So instead of having to worry about some of the other normal processes, you can sign your agreement every time you make a commitment with a did.
Yeah, if you're interested in that, literally you can just Google did get method and you will find the repo Dave Huseby is there's
That's on GitHub.
yeah, the group about a dozen people that really got excited about it at IW, and it's happening fast.
Okay. Thanks, guys.
Thank you, everyone.